Hey, how are we doing tonight? Tonight we are going to be talking about subatomic particles. So we will be doing a vodcast on protons, neutrons, and electrons. Hope you enjoy. Hey, it's time for another vodcast, and the little bad joke in front of you there with the kitty says, an atom says to another, I lost my electron. Are you sure? Yes, I'm positive. See if you can figure out what that means. That's a hint for later on in the vodcast. You got a couple problems that deal with that similar question. First, we're going to start with protons with the subatomic particles, and then we'll go on to neutrons, and then last will be with electrons. And then we're going to take a look at what would happen if you took away or added protons, neutrons, and electrons to an atom. And hopefully you can apply what you see here in these three slides with what you would do if you had to add a proton, neutron, electron. So here's the simple facts about the proton you'll need to know. It's located in the nucleus, which again is that dense point in the center. That can be found right here. Obviously you can see that on that diagram, and it's pointing to the neutrons and protons there. They have a positive charge. You can see protons written as P plus, and we'll get to what the other symbols are for neutrons and electrons also. They're about the same size as a neutron, much larger than an electron if you remember. And a hint to help you remember, pro means positive. If you're pro something, you're positive about it. And again, I'm pro cookies. I love cookies and desserts, and I was looking for the clip from one of the Austin Powers movies with one of the characters who was saying, "Get in my belly," and that's what I was thinking of with my I'm pro cookies. So if that helps you, great. Neutrons are also found in the nucleus. Again, we can see that right here in that center. That's the densely packed center. They have no charge, and you can remember that, thinking nu and a neutral go together. Very similar writings there. They're also located in the nucleus, about the same size as a proton. And neutrons hold the protons in the nucleus. Again, if you had two positive charges together, what would they want to do? If you have two positives together, they would want to repel. So those neutrons hold them together in the nucleus to prevent the protons from flying off and splitting apart. The electrons have a negative charge. They are located in a cloud around the nucleus, as the diagram shows there. That's a pretty good depiction of how the electrons are around. They are moving around billions of times a second around that nucleus, so you really can't pinpoint where they are. So it's more accurate to say they're in a cloud around the nucleus. It's almost like they're swarming the nucleus. You could think of flies swarming around an object, and you really can't pinpoint where they're going to be. And that's kind of what the electrons are doing there. They're moving around very quickly. And again, they're about approximately the size, about 1/2000th the size of a proton. Again, that number was 1 out of 1,836, the size of a proton. So much smaller and moving extremely fast. And again, we'll get into the energy levels as we move on here. We won't spend too much time in this podcast with that. Now keep in mind the overall charge of an atom is neutral, and that is because the protons are positive and the electrons are negative. And when you have the same amount of protons and electrons, they're going to cancel each other out. So let's say we have a carbon atom, and it has 6 protons, so we're going to have all those positive charges. and we'll also have 6 electrons. So a very simple math problem, you'd have 6 minus 6, and that would give you a charge of 0. The neutrons have no charge. There's also going to be 6 of those in the carbon atom. And because it has no charge, and the protons and the electrons cancel each other out, your overall charge of the atom is 0. But what would happen if we added some subatomic particles? So if we had an atom of carbon that had 6 protons, 6 neutrons, and 6 electrons, and we added 1 electron to it, what would happen? Think about that for a second. I want you to pause this vodcast and think about that before you move on. Now, if you said it would still be carbon, that's correct, because it has 6 protons. But now we add an electron, so now we'll have 7 electrons. So if you had 6 protons and 7 electrons, that means you would have 1 negative charge, so it would be a negative 1, so we would have a carbon minus 1. And we would call this an ion. So you may be asking yourself, what is an ion? So ions are atoms that are either positive or negatively charged, and they're going to be positive or negatively charged due to the fact if they've gained or lost an electron. If they've gained an electron, then they're going to have a negative charge because they've added an extra negative charge. If they've lost electrons, then they're going to have a positive charge because there will be more protons than there will be electrons. So you're going to have a positive charge. Usually this happens when energy is added into the atom. You see this a lot, and we talked about this when we were in astronomy with the sun and the plasma, the ionized gas. In this picture here, all these nice colors right here. This is the aurora borealis, and this is ionized gas in our atmosphere that's been electrically charged, and it's our magnetosphere that's kind of highlighted, and we can see these gases excited and electrically charged. So this is ionized gas in our atmosphere. So this is a plasma or an ion at work. Alright, another question for you then. What would happen if we had an atom of carbon that had 6 protons, 6 neutrons, and 6 electrons, and we added 1 neutron to it? So what would it be? What would it be its overall charge? I want you to pause the podcast and think about this one. The answer here is that if you add a neutron, the charge doesn't change, because remember, neutrons are neutral. Remember the neutral. However, this would now be an element called carbon-13, which is an isotope. All right, an isotope is going to be something important as we go on here with radioactive decay. So it's still the element carbon, but now it's an isotope of carbon. And we call it 13 because it has 6 protons, and now it has 7 neutrons. So we add those two together, and we call it carbon-13. If it was 2 neutrons are added, then we call it carbon-14. You're just adding up the protons and the neutrons, and that gives you the name of the isotope. So what is an isotope? And isotopes are elements that have different number of neutrons, and they should, so they could be added, they could even be taken away. The larger elements, when we get up in the 90s, especially like uranium, they get really unstable. And what that means when they become unstable, think about again, when you don't have the right amount of neutrons in the nucleus, what are those positive protons going to want to do? They're going to want to split apart, and that is a radioactive decay. They start to break apart, and they start to break down, and that's what radioactivity is, and we'll get into that more when we get into our carbon dating and radioactive decay next week. Okay, final question. What if we had an atom of carbon that had 6 protons and 6 neutrons and 6 electrons, and we could add on a proton to it? What would happen to the atom, and what would be its overall charge? Again, pause the vodcast and think about this question. So hopefully you kind of caught this pattern, and you realized that it had 7 protons now, and you know that if we have 7 protons, then it is not carbon anymore. Now it is nitrogen, because the number of protons corresponds to what element it is. If we would have taken away 1 proton, then it would have also changed that element. If we would have added 2, it would have changed the element. So if we're changing the number of protons, then that changes the type of element. The overall charge would now be positive, because there would be 1 more proton than there is an electron. Alright, so after watching the vodcast, here's what I want you to do. I want you to make a triple Venn diagram of the 3 different subatomic particles. So I'd like you to make a triple Venn. We're going to do the 3 circles, and you're going to put your protons in the top left, you're going to put your neutrons in the top right, and you're going to put your electrons down below there. Now what I want you to do here is put your similarities for all 3 in the center. So let's put 3 sim here and put 3s. And then right here, these 2 similarities, and then these 2 similarities, and then these 2 similarities. And then right here, these will be your differences for each. So go back through this vodcast and then check out what would be the similarities between the subatomic particles, and then what would be the differences. And that will be your assignment after watching this VOD. Thanks for watching, and enjoy your night.